so let's try to do housings. So I'm going to get into equipment types. We never talked about what mobile is, or you know, in detail, and so maybe we should have done it sooner. But with the enclosure testing, I figured we'd introduce it here. So a good deal of our material will be about that. But then we do wrap up and start talking about the abuse type tests. And again, abuse and abnormal condition, and we're responsible for these kind of strength type tests. All right, so over here, I'm going to try to list the equipment, and over here, I'm going to talk about supply connections. So stationary equipment is a word that actually, fixed equipment's a subset of stationary. Fixed is, it's really bolted to the wall or the floor or the ceiling. And stationary is, it's just, it could be that. So that's also stationary. And then there's the other than fixed, which isn't a word. You know, it's a phrase. And so there's stationary equipment that's not fixed. And that's because it's so heavy, it's unlikely to move. Yeah. And that's just the way the words fall out, you know, to be technical. And then handheld equipments of stationary equipment. So I kind of wanted to introduce handheld. It's handheld during use as defined, but it's kind of tied with a cord to the stationary equipment, you know, fixed or otherwise. And so keep that in mind. You know, if you're reading handheld applicable tests, you might say, well, my equipment's stationary. But there can be handheld parts of stationary equipment. In any case, stationary equipment has to permanently installed. So in North America, we use conduit and raceways, wireways. We kind of enclose the building wiring. And so you're compatible with those sort of things, because you want to be compatible with the national code. And so I'll mention that. In Europe, it's more common to use the pin and sleeve industrial plug socket, if you will. There isn't the same, you know, conduit or wireways. But in any case, that's considered permanently installed. And then you need to bring the wiring in. I suppose if it's the European industrial pin and sleeve stuff, it's more or less plug and socket. But sometimes you're bringing the wire into the device, and in North America, that would always be the case with permanent. And that's called the mains terminal device. And in the US, we'd call that the field wiring terminal block. It's the one the electrician needs to interface with. So with permanently installed equipment, that word's relevant. And then I mentioned it there. Good. All right, so this is the big stuff. And then we have a big word called transportable. So all medical equipment is stationary or transportable. Okay, so this is a big word. And subsets of transportable is mobile. And we saw the cart, you know, that sort of idea with wheels. A hospital bed probably has wheels, the trolleys, if you will. Portable equipment is your tabletop kind of things that you would carry from place to place, but usually not use while you're carrying it. And then body worn is a new term. So the home care introduced this word, and then the general with the amendment, Amendment 2, adopted it, you know, the 2020 Amendment 2. So it's body worn during use, right? So an infusion pump for insulin, you know, an LVAD battery pack. Handheld equipment, it's got to be handheld during use. Yeah, so your blood glucose monitor is handheld during use. Yeah. And then on the supply connection side, just so you can get used to the words and then where to find some of the requirements. So transportable equipment, there's what's called an appliance coupler, and I think that's referred to more often as an appliance inlet. So it's the detachable cord, the plug, if you will. On the equipment side is the inlet, and then you have kind of a connector or a socket on one end of the cord set and a plug for the compatible main socket on the other. But the equipment itself is considered the appliance coupler with the box, if you will. And that's always a detachable cord. And we kind of talked about cords a little bit in the fire thermal section. And we'll talk about them again in the component section. But you can also have a non-detachable cord. Okay, so it doesn't detach. It's kind of permanently in there. So then you have the strain relief concerns, the flexing, the yanking, flexing, and isn't there one other thing? Bending. There's a bending radius thing. But the other thing I want to talk about is that mains terminal device again. So now with a non-detachable cord, we need a means to change cords, especially from a European point of view. If we drive, as little as a couple 100 kilometers, we're in a different country, maybe a different cord, right? So, or plug. So we intend IEC 601 or the EN version both intend, and the Americans didn't modify this. We intend it to be rewirable. And so that means where the cord and its strain relief means gets replaced is part of this rewirable requirement. The mains terminal device would be part of that. Or it could be we're just taking the plug off and putting a new plug on. The mains terminal devices in the plug. There's requirements for marking. Where's the ground, where's the neutral. And then some transportable equipment could be internally powered, battery operated, right? So here's a Venn diagram, and in fact, it's in the annex. And body worn, subset of this, subset of that. Handheld parts can be part of all sorts of things or handheld on their own. Okay. And then I want to introduce a word from the home care standard, transit operable. And I call it Transop because it sounds cool. SIP-SOP, Transop, MOVE-MOP. But transit operable means it moves while it's being used. Okay, while you're operating it, it can move. So this is maybe a ventilator of some sort or oxygen concentrator, and it's on a wheelchair. So obviously the wheelchair moves while it's being used, but you may not have thought about a ventilator moving while it's being used, but you need to think about that. If that's your intended use, then we have this word. And so all body worn and handheld equipment's probably transit operable, but not necessarily. It would just be, that would be two categories where it's common. So there's some requirements about ingress and shock and vibration, depending on whether you are or you aren't. And this is all home care only. And the IP comes up a lot, so we'll look at that. So if it was for use in a hospital, there's no IP requirement. If it's used in the home, all of a sudden you have an IP2. And remember, 2 was the 12.5 millimeters, was it? And you've already, and the finger's 12, so it's almost automatic. But the 1 is the strip test, and the 2, the second 2 being the drip test with the 15 degrees. So home care There's a lot of active implant accessories, or the insulin pumps and the glucose meters, where they're handheld or body worn, and they would need these tests. And so a lot of legacy ones got caught up with this stuff. And of course, you're going to maintain basic safety and essential performance. And I suppose the idea is that in the home, you know, it's the whole Pepsi syndrome thing, the Coca-Cola, whatever, it's flying around and falling on everything. Okay, coffee. Which is why we should do a 200 milliliter spill test, I guess, for, you know, Budweiser and Carlsberg, depending on the patient. All right, so then I put transit operable on here for you. All right, any questions so far? So we know what types of equipment there are, and we're going to see that depending on the type they are, we do different tests. So the enclosure requirements could be kind of rewritten with this flow chart, and I think it'd be clear. But the first thing you should ask yourself about an enclosure, or a portion of an enclosure, is that enclosure a risk control for a hazardous situation? You know, are there dangerous voltages? Are there moving parts? Is it supposed to contain a fire or protect against a burn? Is it protecting against excessive radiation on the other side? Is it protecting against the ingress of fluids? Is it somehow essential for essential performance? You know, necessary. And so if it is a risk control, then we should do some thermal resistance and mechanical tests, okay? And maybe shock and vibration, although that's generally not required, at least in the general, other than subtly. You have to have fixing of components in 8.10, but there's no test specified. And then you would do these tests, these mean and hateful things to your enclosure, or demonstrate these thermal resistance. You know, more probable you'd be sourcing materials that already have the thermal resistance you need. But in fact, there is a ball pressure test that we might do. And then in addition to those mean and hateful things, we would then not just, you know, so you're checking for the integrity that's been maintained, but you're doing that in a sense that, have we maintained basic safety and essential performance? But there is situations where an enclosure or parts of the enclosure don't provide that risk control. And so then the concept is, yeah, fine, it's decorative, you might say, okay, or non-risk control functional. Okay. On the other hand, biocompatibility is always an issue, right? All right. So with electric shock, we're generally told to think about the finger probe, but also whether there's loose parts, whether you've had, you know, so the finger probe can check that cracks and things are bad. With moving parts, it's sort of the finger probe again. And with burns, you know, you're able to check a temperature of what's accessible. Fire, it's your 11.3 construction stuff. There's limitations on openings in the bottom, I suppose. That's our criteria. Radiation, you would be checking radiation levels, unintended ones, or intended. Generally, the unintended ones from the enclosure after these tests. Liquid ingress, you might actually have to do the ingress again. And if you think about that spill test and that single fault phrase, it starts to make sense if you think about it in this sense. So the single faults My example was the alarm situation, where you want to be able to still detect an alarm condition. Here, you'd still want to be able to do a drop test and pass the spill test. Okay. So thermal resistance is, so if we're doing our risk control job, then one of the components of that job is to verify thermal resistance. And so we could source it with a UL relative thermal index. There's an electric, a mechanical with impact, mechanical without impact. These are kind of explained in the plastic UL recognition for these plastics. So I'll let you read about that. But if you had the temperature rating for the appropriate rating, so an enclosure would be, subject to impact. So you'd look for a relative thermal index with impact. If you had that, you would probably document that you had sufficient thermal resistance. There's I don't know if I can pronounce that. Is it VICAT or VICAT? But there's an IEC softening kind of test. If you had the temperature rating consistent with your use, you might say you're good. But otherwise, the standard says you would do a ball pressure test. And this is the 20 Newton weights. This is this 5 millimeter diameter ball, and you can't have more than is it a 2 millimeter diameter in D10. So you're in an oven for is it a 75C oven or 10 degrees more than your normal use, and not less than 75, I think. And so you're looking for a more than 2 millimeter diameter. And there's a CB guidance document on how to treat the little push away waves and things, and how you have to preheat your ball pressure apparatus. All sorts of good stuff. You should get that guidance if you're doing these tests. Here's a picture of a front enclosure. It's a bit of a mess, but I suppose it kind of shows you the tricky balancing acts. You don't want it a little crooked because it actually slides. And then you get instead of a detent, you get a groove. So there's a brick that we generally use. Of course, it's preheated so that this can balance, the below the sample under test there. There was weight here, so we put a little weight here, just so nothing moved. And it looks like there was a bit of a balancing going on. It's very important to be level. And so, crazy as it is, so after an hour, you check that there. Okay. And I don't have a picture of what that might look like, but that's all right. So that's thermal resistance. So you sort of have this warm flow idea. We shouldn't have too much warm flow, okay? But then on the mechanical side, sorry about that, depending on the type of equipment you are. So here's handheld, body worn, portable, mobile, fixed, or stationary. I could have just used the word stationary. There's a push test. So there's a 250 Newton push. Is it 250? Yeah. On the enclosure, and it shouldn't dent or break. And so that's done on pretty much everything. Yeah, everything. Body worn, yeah, everything. And then for body worn, portable, mobile, fixed, or stationary, so everything except handheld, there's an impact test with a 50 millimeter diameter ball. And it's equivalent to a 1.3 meter free fall. So you either drop it, and if you have a tube with enough holes to let the air out, that's very good for aiming. Or you attach it to a string, and it, like a pendulum, it falls through a vertical of 1.3 meter. And that's, afterwards you're looking for damage that would have affected basic safety or essential performance. So no live parts, etc. Handheld gets a drop test instead, and it's a 1 meter drop. Okay, and then that's to hardwood, and there's 3 drops, I guess. And if you're portable, you've had the impact, but you're also going to do a 5 centimeter drop or less. If you're heavier, it's less. If you're on the lighter side, it's never more than 5 centimeters. So that's 2 inches, if you will. Mobile. So if you were mobile, you had the impact, and then you would also have these rough handling tests. So they're kind of a shock test. You hit a step that's going up. There's a step going down that you go down, and then you bang into a wall, a little like the molding around a door. You bang into that. Is it 3 times? Who knows? Do I have that? Yeah, it's here. So we'll look at that in a minute. And then handheld, body worn, portable, mobile, fixed, or stationary. So that's everybody. If you had a plastic enclosure, there's a mold stress test. So this sort of checks that thermal resistance again. You're going into at least a 70°C oven, or 10 over your operating temperature if it's higher. And it's 7 hours. And if it warps and distorts, and believe it or not, when you injection mold, you kind of capture strains. And if it gets warm, sometimes it'll, the strains get relieved and it ends up in warpage. So it's not so common you'd fail that test. When I started out in the 80s, a lot of equipment failed this test. So we're a lot smarter with our plastics. Anyway, it's still required. And so that's, I suppose, more related to thermal, but it's in 15.3, so I included it with the other mechanical. There's some rationale about the 250 push test, and it's a pressure. It's a force on a cross-sectional area, and if you test some applied parts, like a $20,000 endoscope, that's a little too mean and hateful. And there's some other concerns that went into that endoscope's design. And maybe mechanical protection needs to be weighed against, flexibility and the fact that it has to be sterilized a lot, and et cetera, biocompatibility. And so maybe we should go back to the 45 Newton test from the second edition. So that's not a requirement, but that's the rationale, saying it's possible you would want to use risk management and pick a more appropriate test. So I want to make sure people are aware of that. Here's that mobile equipment rough handling. So here's your up step, and you bang into it. You don't have to go over it. You just have to bang into it. If you do go over it, great. But if you bang into it, it's not a stability test. So you bang into it and you don't let it fall over. It's meant to just administer a shock, if you will, a mechanical shock. And, are there loose parts? And if something like this, did the wheel break? Try not to hurt anybody. So it is 3 times. And then this 0.8 meters per second is just barely a quick walk. And there's a plus or minus 25% tolerance accuracy on that. And so the intention really is that you would calibrate yourself to walk that fast. So you kind of practice, and then you go and get the equipment and do it. And that way, the intention was you don't have to build special calibrated, pull the equipment with a cable at exactly that speed with a a tighter tolerance. The plus or minus 25% more for just a human test operator would do it. 40 millimeters down test, 3 times same speed. Okay, and there's your 40 by 40 door frame, and you're sort of banging into it like a wall, square perpendicular into it. Same, slightly faster than normal walk. So 0.6 is probably a normal walk. Here's your fixing of components. So I did include this in kind of the enclosures. So in the general standard in 810, it says you make sure you fix your components well, and the verifications in the risk management file. So there's no test method or even well, the compliance criteria is kind of there. There's no unacceptable risk. Loose parts, no loose parts. So that is a risk management result formally with OD 2044. Now in the home care and the 1-12 emergency medical services, there's actually a formal shock and vibration test. So I want to make you aware of that. If you think about all the monitor standards, the pulse ox and the ECG, there's actually a formal shock and vibration tests in there, and they're the same as the home care ones. And they come out of an IEC 68, and this 60721 is defines classes of abuse, if you will. And then the 68 2-27 has tests for each of these classifications.